Hi, welcome to College Algebra 5.3, Properties of Logarithms. So, three main properties we're going to use. What's called the product rule. Product, by definition, means to multiply. So it just means if I'm multiplying two things inside the logarithm, I can break them apart as two separate logs using the addition sign. Quotient rule, same idea, means to divide. You would then use subtraction to break them apart. And power rule means, that you have some sort of exponent. You can take whatever the exponent is and put it out in front. Okay, here's just an example. If I had log x cubed, I could put that 3 out front and write it as 3 log x. Same idea, using the product rule, I am multiplying all three of them, so I could separate them with plus signs, and I get the exact same idea there. We use these to do what's called condensing or expanding. Condensing means bring two logarithms together. I have the same log separated by an addition, so I can multiply the inside to get the inside number there. In that case, it's 12. Or what's called expanding. Break one logarithm, so I'm dividing, into two using the property. So in this case, I'd break it up into subtraction, 7 minus 2 there. Rewrite using properties of logs, sums or differences of logs. So here I have natural log of 6. It just says to expand. So in this case, I can rewrite this because like 6 times 1 equals 6. I could write this as natural log of 6 plus plus natural log of 1. Funnily enough, if you remember from earlier sections, anything to the log of 1 is 0, so I still get natural log of 6. Otherwise, I could have done it as, natural log of 2 plus natural log of 3, because 2 times 3 is also 6. Either one would have been just fine. Here we have a little bit more written direction. I have the divide sign, so I'm going to separate them through subtraction. What the heck? Yep. It's important to also note that whatever your starting log is, whether you expand or condense, it's got to be consistent. So this is log, so I just kept it as log. In this case, we have log base 2, so I'm going to have to keep it as log base 2. Now, I also have the cube root of 5. We haven't talked about radicals really, but if you remember from an earlier unit, as well as way back in Algebra 2, I can rewrite any sort of radical as an exponent where whatever the root number is also goes as its denominator. So this 5 currently has an exponent of 1, so I can rewrite this as, log base 2 of 5 to the 1/3. And now I can use the power rule and take this 1/3 and put it out front. So I get 1/3 log base 2 of 5. Okay. Same idea, but now I'm going to expand, or I'm expanding again. So I am multiplying all three of those things. I have to keep the log 4 consistent, so log 4 of 5 plus log 4 of x cubed plus log 4 of y. And then I see I have this exponent of 3, so I can put that out front. So log 4 of 5 plus 3 log 4 of x plus log 4 of y. Here I am dividing, so I could do subtraction. So natural log of the square root of 3x minus 5 minus the natural log of 7. Just like earlier with that cube root I had, I can rewrite square root as an exponent. The square root would be to the power of 1/2. So now I'm going to take that 1/2 and put it out front. So I get 1/2 natural log of 3x minus 5 minus natural log of 7. Now, some people might see this 3x and say that's multiplying. However, 3x minus 5 is all one factor. So I don't have just multiplying or dividing in there, I have that subtraction. So I have to just leave it as is. There's no more I can break that down. If it was just 3x, I could do 1/2 natural log of 3 plus 1/2 natural log of x. The 1/2 would follow with both of those. But because I have this minus 5, I cannot do that. Okay. Here, we're going to condense the opposite, so I'm subtracting, which means I'm going to first make sure that these are the same. Yep, they're both log base 3, so we're all good. And then I could just do 15 divided by 4. Here, first, I'm going to put this 3 as an exponent of the z. So natural log of x plus natural log of y minus natural log of z cubed. I have x plus y, so they're going to be multiplied, minus z cubed, so that's going to go on the bottom. So natural log xy over z cubed. Same idea, put the 2 up top. I have minus log y and minus 5. So both of those are going to go in the denominator. So log of x over 5y squared. Okay. Let's try a couple more. Why would we use this? Well, let's say I have something like log base 5 of 100 minus log base 5 of 4. If you didn't have a calculator, this would be really hard to compute. But using some tricks, I can see I'm subtracting both of those, so I can condense them into 100 over 4, which gives me log base 5 of 25. Now, a really important property that we need to understand is if I have log base x of x to the a, that equals a, because these two things, log base x of x, eliminates itself and my exponent is remained. So whenever I have a number right here, I should try to express it as an exponent of this number. So because 25 can be written as 5 squared, if I write this as log base 5 of 5 squared, those numbers match, this whole thing simplifies out, and I'm just left with 2, which means log base 5 of 100 minus log base 5 of 4 equals 2. Well, let's try something a little bit different. Let's try log base 3 of 1 over 27. Now, even though it's a fraction, 1 over 27, it doesn't matter too much because we can all agree 27 is just 3 cubed. However, this 27 is in the denominator. Well, if we can remember back in Algebra 2 and earlier this year, if I ever have a negative exponent, so x to the negative n, that gets put in the denominator, which means this whole thing, 1 over 27, is the exact same thing as 3 to the negative 3. So I'm going to replace it and rewrite this as log base 3 of 3 to the negative 3. And again, these numbers cancel. So this whole thing equals out to negative 3. I can even go one step further. Let's say I have log base 16 of 2. Well, this one's a little bit weirder because 2 can't be written as 16 with an exponent, but it actually can. So if I ever get something like this, I should try to break down this number. So for example, if I break down 16, that's 4 times 4, or 2 times 2, 2 times 2. So interestingly enough, 16 is 2 to the 4th. Well, I am not trying to replace 16. I'm trying to replace the 2. So in this problem, I could fourth root both sides. So by this logic, 2 has to be the fourth root of 16. Well, as we've already discussed, I can rewrite radicals as an exponent. So this is actually 16 to the 1/4. So I can use this and plug it in right there. So I get log 16 of 16 to the 1/4. These numbers match. My answer has to be my exponent. So those are some of the ways that you can apply that. Basically, you want to aim for these numbers matching in some way using exponential properties. And lastly, we have what's called the change of base formula. It's used often if you don't have a calculator that can change this number. You can just use either the natural log or the natural base for logarithms. So for here, instead of typing natural log of 3 of 16, you would get log of 16 over log of 3, or natural log of 16 over natural log of 3. This was used back before calculators existed, so in a way, or most common calculators existed, because memorizing or at least writing down every single possible log would be impossible. So they reverted to figuring out a way where they could use a natural base of them. So here, for example, natural log of 4 divided natural log of 7. Thank you for listening, and I hope you have a great day.